Hi, and welcome back to the Redcar Analytics Learning Path. My name is Neil Bolger again, and in this video, we are going to go over the idea of modeling with a purpose. I want to take a second and step back from the details of how we build a model and kind of give some guidance on what I've found to be successful ways to use energy models, as well as how I have thought about, creating them and the process of creating them. And really the purpose of it, like how to get the most out of it. And so a simple diagram, sorry for how crude it is, that I drew a while back that I actually saw someone else draw a similar sketch to this, is this idea of the value of making an energy model. There's lots of reasons to use them, not just for designing buildings, but the purpose still uh, resonates, no matter if you're using them to design or run them for energy analysis to understand a utility program or anything. There's still this relationship where basically every model has some setup phase, and that requires time. So if time is here on our x-axis and the value is on the y, that setup phase takes time. And the whole time, we're not getting any value out of the model. You might have to fix geometry problems, space names, all sorts of things, inputs. And then there's a validation phase, right? Now the model might be working, but we don't really know if our definitions of our air conditioning is correct. Maybe we're trying to get the lighting to be more accurate to represent how it should work. So we're basically validating it, validating it to be a useful representation of our building or that we're designing or whatever it is. And then we have this phase, where we're really the goal is we're trying to cross this threshold, use that model to inform design, use it to inform changes, be it in an incentive program or something else. And more often than not, time falls short. You end up having this very small window of value, and maybe you use the model to come up with one answer or one comparison of that configuration with a baseline. And that's all we really get the value out of it before it's too late. So, this can really help inform thinking about how do we actually make energy models to be useful from the start. So there's lots of ideas out there. This idea of accuracy as a design might increase in complexity. Here we're showing it from geometry, on the left being very simple to very complicated on the right. And you might end up making lots of energy models of the same building, but you can make something very quickly here to get answers out of it and then just move on to the next stage and just continuously build another model. Another strong thing I highly recommend is almost working backwards before you even start an energy model. Start by saying, what are we delivering? Is it a report? Is it a scorecard? Is it a table, an Excel file of tables? Who's going to read this? Is it someone that knows how to read spreadsheets and likes lots of nitty gritty numbers? Is it a client who maybe who the architect works for and doesn't understand buildings? Is it the state of California? Who is getting the results will definitely change both the type of analysis and really the amount of charts you have to make and how you have to communicate where you got your assumptions from and what it is you're actually comparing or solving for. And so if you think about what you're delivering first, you can then kind of come up with this idea of the outline. Even before you know answers, you should, as an energy consultant, have a general sense of what type of a model are you going to build, what are the questions it's going to answer, and then the model is really used as your tool to understand the magnitude of a lot of those answers. Very, very unfrequently is a model used to answer a question that we have no idea the answer to. If it's thermal comfort, we generally know that shading will make people a little more comfortable. We generally know triple pane windows will make people a little more comfortable. We generally know both those things will reduce energy. By how much? That's usually the question most models are answering. So in that sense, you might know actually the type of chart you need to make. You might actually know where you would anticipate a model to show you the energy savings. Probably not more than 50% if it's a simple measure. Um, and so you can actually start to lay out what your report's going to look like, all even before you actually pick your energy modeling tool and how you're actually going to solve this value to time challenge that we're all underneath. So, work backwards. It's the key to life. So, we talked about this time to cost. You saw it in that other diagram, but, this just represents how accurate an energy model is. Accurate, totally relative word, accurate to what? But let's say it was accurate to, in a design case, how much energy the building might actually use based on how much time you put into making that model. There's lots and lots of things that change a building. How many times people come in on Saturdays versus Sundays, or the weekdays. That's a very sensitive subject to, or lever to a specific building, and that time to actually figure that out, ask people, it could take a lot of time, and so you would see here the time to kind of maybe tweak some of those things might only change the accuracy a little bit and take us a lot of time. So really the goal is, how do we spend the least amount of time and try and get into this 80% accurate range to really then use modeling for comparative studies, one model versus another, where we can kind of normalize out a lot of these unknowns, and make wise choices about building energy systems. Another thing here that we'll get into in the future as we talk more is this idea of self-validation of an analysis, which is a huge challenge. But as an energy modeler and energy consultant, more times than not, you will be given very short deadlines and need to check your work and make sure it makes rational sense. And there's lots of ways to do that. There's lots of great touch points you can look at through a model. The great way to do that, especially when thinking about simple models and complex ones, is if you have a model that's able to tell you something about the mass, the space use, thermostats. There's ways to almost simplify all of the air conditioning very, very quickly to say, well, this air conditioner is about this efficient, and if I know my load, I can estimate the electrical use. And so we'll look at some ways to help use simple models to almost troubleshoot more detailed ones. But again, there's no right way to do this, but it's of utmost importance. So, with that, I'm going to walk us through some basic introductions to energy modeling for those that are not familiar with it, and just kind of walk you through my process of how I start from nothing and then build it up to a full model. I think actually at this point I'll stop here and then we'll go on to a second video of this series. All right, thanks.